Okay, do you see my slides?
Yes.
Okay. So, Assalamu alaikum, everyone. In this session, I will talk about generative AI and prompt engineering for application building. In this hackathon, you are most likely going to use a coding platform or vibe coding platform that we call, right, where you provide a prompt and then you are able to build applications. You might also choose to use the same type of prompting for generating code like Python code or C++ code or Java code for your application. But this is geared towards the platforms for building application like Base 44 or Lovable or Replit, those type of platforms. So I will walk you through today from the beginning to some very concrete examples that will be very much applicable to your scenario. A little bit about myself. I am Mohammed Islam. Um, I am a systems engineer and also a graduate faculty at the George Washington University. I teach master's level classes and also I teach and advise doctoral students. And a lot of the work I do is with AI and machine learning. So, what I'm telling you really is very practical. And this is something that I work with my student researchers and also something that I work at my day job. And we do apply this for solving real-time problems. So first, let me give you some background. What is generative AI? You probably know generative AI it's an umbrella term. Like we call chat GPT. That is a type of generative AI. There is other types of platforms that will create a schedule for you, create a picture for you, create music for you. There is almost any form of digital asset that you can think of. These AI platforms can create that for you. So anything that can create new materials means a new picture, a new music, a new letter. Because they are new, they are not copied and pasted from somewhere else. They are called generative, right? They are not copy paste of something existing. Generative AI utilizes advanced algorithms like deep learning techniques, transformers to create outputs, and they mimic human like creativity and also originality. They have some originality, even though many texts that you receive from a chat GPT or other platforms can look like they are copy and paste of things from Google, right? So, but they are generated by GenAI. And there is another property of GenAI, which is it might generate different answer every time. And let me clarify that, what I mean by different answer. If you ask ChatGPT right now, you can try that. What is the capital of Germany? All right. ChatGPT might tell you Berlin, or it might tell you the capital of Germany is Berlin, or it might tell you Berlin is the capital of Germany. Okay. In all sense, we understand what we are trying to get is Berlin, and we got Berlin. It didn't tell us London. Then it would be a mistake. So if you ask ChatGPT a question that has a very definite answer, it will give you the definite answer, maybe in an indefinite form. Indefinite form means the capital of Germany is blah, 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 or blah, blah, blah is the capital of Germany, right? It has different way of saying it like a human, but it is telling you exactly what you want to hear. On the other hand, you might ask ChatGPT, can you please write me a letter asking for, you know, leave of absence from my school because I have an appointment with my doctor or something like that. In that sense, it will create a letter, first try one letter, second try one letter. If everybody tries ChatGPT, it will create a different version of letter for them, right? So for some questions, GenAI will give you a varying level of answer. For some question, the answer is going to be very fixed. And it is based on the context and the training, right? So that is one of the property of GenAI. So as I mentioned, we can use it for generating text, generating code, generating images. Images, if you think about, are really, what is an image consist of? Like what you are seeing on the screen right now, right? If your screen is 1080p, it has fixed number of pixels in your screen. And each pixel is actually telling you, something like if you see this pixel in the screen, like most of the screen is white. So this pixel that my mouse is, this is a white pixel, this is a black pixel, right? So all the image is black and white or different color pixels. And those can be expressed by numbers. And a Gen AI system can actually manipulate those numbers and they can create different images. Same thing with voice, music composition, right? A voice or music is really a signal that has zeros and ones and a combination of that. And that signal, Gen AI can read, they can manipulate. And there are many other applications that are used for generative AI. It takes our existing knowledge, it uses advanced techniques like neural network, right? Neural network is a, each neuron, just like our brain, does one function, gives us one decision. When you are stopping at a stoplight, think about this, the billions of neurons in your brain, right? Not the billions of neurons are looking at the signal, maybe a subsection, maybe, a few million. And the few million are all trying to decide that is it a green light or a red light? And hopefully, all of them sees green light as green light and tells you that they are green light, right? So you can go. And that is a poll. So same way, we have artificial neural networks or convolutional neural networks, that will actually poll things. This is like a democracy, right? So a lot of time you see that human hallucinates or large language models hallucinate. This is when, some of your neurons vote one way, some of your neurons vote another way. And that is a deeper discussion, but you know that this is actually the result that you are getting is result of some very complex system, right, of thinking. So what is the difference between Gen AI and predictive AI? Gen AI creates content, predictive AI actually predicts the future, right? Gen AI can create like human-like creativity. They can be trained with different types of data. They can support innovation in different industries. They are like a research engine, right? Given what we know, it can try to predict what we don't know. And predictive AI has limited understanding or context. It is trained on a very specific problem and gives you some prediction based on that very specific topic, right? If you ask a predictive AI engine something random, right? Like you train some images and then you ask, to write a song. Predictive AI will not be able to do it because predictive and generative AI has a lot of freedom of creating new content that the predictive AI doesn't have. How is Gen AI possible? Because we have diverse data sets, we have very large computational capability, and then also they are embedded into deep learning models, or deep learning models are embedded into them. Whenever we are using ChatGPT or some other Lovable or any other platform that is basically running generative AI on the back end, there is a data center somewhere which is providing all this power, right? That's why you hear a lot of conversation nowadays that investment of billions or possibly trillions of dollars in data center infrastructure. If you live in the DMV area, right, all this discussion in Northern Virginia about data centers, and whether we should have data centers, whether we should not have data centers, and the environmental impact. The boom of data center is because of the growth in usage of AI. Okay, so we will learn about some of the statistics, in here, like two news articles that I just read recently. In through 2028, we are going to see globally $2.9 trillion of investment for data center construction. So this is actually increasing. AI platforms and models are growing by 63% their market share this year, right? So every year, the market share is increasing. And with that increase, the amount of usage of Gen AI is increasing, right? And also they are becoming widely accessible. You can pay for Gen AI. You can also use them for free. Like if you go to ChatGPT, Claude, or even Lovable, you are able to actually use them for free for certain, time, and then you have to subscribe. Their accuracies are getting into a critical point. You will see more and more accurate results because of the reinforcement learning. Previously, a lot of the large language models would be giving you wrong results. Now they're giving you better result. So if you want to understand large language models and Gen AI, the difference between them, if you think about this, we have some foundational models like BERT, GPT-4, Llama, right? These are actually, these are like almost, if you can think about like Unix operating system. These are very raw. These are actually generated by different companies or developed by different companies, and they're put out there. They are trained using vast amount of data, and they are fine-tuned for language understanding and generation task. So if you take one of these foundational models and now you want to brand that with your own brand, maybe you train using some specific data set like music, and also you create it for a very specific purpose and you deploy that. That's when you get the large language models that we can use, and you add a UI or some other type of interface to access that. So large language models are actually subsets or specific sets of foundational models that are modified, right? How do they work? Just to, if you are a user, like if you are using this for your hackathon, think about yourself as the most left-hand side. You are giving a prompt. Your prompt is going through an application interface. You may be seeing a website and it will have maybe images, it will have the application. You are interacting with that. When you put your input, it goes to a large language model engine. It works through that through some API, and it gives you the output that you can see and render, right? So mostly, these are the areas that the work goes on in the prompt, in the application interface, and the LLM in the output. Our focus today will be more on this level in the prompt. What you can do as a prompt engineer to get the best result. Because you might not be able to make any changes in the application interface. You will not be able to make any change to the LLM layer, right? This is kind of locked. And also, the output is going to be dictated by the LLM layer. So the way that we will be able to make changes, or we will be able to make interactive decisions or interactive applications is within this prompt layer, which is what we're going to talk about. This is a little bit more in depth. So we have, as we are using with our large language model, we can either provide a prompt, we can provide some chunks of information like books, scientific research, data, data sets, and then we can have tokens that will actually utilize as these large language models are working. Tokens are basically the feed, that this is how the more tokens you use, the more charge you get, right? This is a way to basically how you can measure, utilize your human feedback. This is where you are actually coming and saying, well, can you build me an application? Or what is the capital of Germany, right? Somebody has to train that large language model that the capital of Germany is such and such city. And then you get your output, and that is the decoding. So encoding and decoding model is the model that we are using in the large language models. And I took this from OpenAI and Databricks, and so this is a reference. All right, so in the prompt engineering, let's talk about the definition of prompt engineering. Prompt engineering is really an art of effective inputs that will guide your AI's behavior to produce reliable and relevant outputs. Why do we use it? We use prompt engineering because we can generate accurate and context-aware code. We can also, automate repetitive and complex tasks, and we can interact with the data. And the better prompt engineering we can do, the better responses we're going to get. We can reduce hallucination, we can enhance performance and reliability of these applications. So these are some of the techniques that I will talk about. And hopefully, this is where we are coming into the practical application of what I have been talking about. So I gave you a lot of background, some boring stuff. Now we're going to go into some hands-on activities on how we can train large language models using prompt engineering, or how we can interact with large language models with prompt engineering. So this is just an overview chart, the market share. You can see this is actually, a little bit old, but, think about this as almost, doubling every year, right? So we have ChatGPT, Bird, we have, Quillbot, we have many other LLMs that are being used right now for different tasks. All right. So the first prompting technique that we have is called zero-shot prompting. This is the most basic form of prompting. Okay. Zero-shot means without providing any context. This is where we ask the model to perform a task without providing any examples. Here is an example of a zero-shot prompt. So we are asking, let's say in Replit or Lovable, build a habit tracker web app where users can add daily habits, check them off each day, and see their current streak. Give it a clean, modern UI. So what I'm going to do in this, for just this one, I will go into one of these platforms and then show you how it works. Lovable. This is one of the platforms that you can use. You can use almost. Okay, so let's say I give this prompt. The same exact prompt that you see, it doesn't have much, right? Much context. but it will actually build you something. So let's give this prompt. A habit tracker web app where users can add daily habits, check them off each day, see their current streak, give it a clean and modern UI. So if you give the same exact prompt, the application that it will build versus the application that it will be building for me is going to be somewhat different because this is a very generic prompt. So we are just waiting for it to generate. And again, each of these prompt will take a while to create an application. So I'm just, showing you the first one. After that, we are going to go through them, rather very quickly. Does anyone have any question? Okay, give it a minute. So you can see it is building different files. Okay. This is the index file or the main file it's working on. Okay. So this is a very simple example. Smallest steps every day. And okay, so you can actually go in. So I can add a habit. Okay, let's say read for 30 minutes. Then I can say walk for 20 minutes. Okay. And then you can actually say whether you have done it or not, right? All right. Again, this is just a application that you and I are seeing for the first time, right? And I don't even know, you are adding a habit here. So I added two habits, right, that I'm going to do today. And I don't even see any option to actually check mark that I have done this. I see an option to delete, right? It is not very, at least, in my case, I do not see anything how I can, besides adding, how I can actually mark that I have done it today. Okay. So yeah, it builds something, but if I want to now, add a realistic marker to tell me how I can add my progress, uh, I have to ask it, right? Or I don't know how to do it. I have two habits, but I don't have any way to record them. And if you delete that, it's deleted, right? So now we only have one habit. Okay. Oh, yeah, here you go. So one-on-one is done. Okay, good. So let's say walk for 30 minutes. Yeah, okay, I just found it. It's right there, right? So build a very simple app. And with this platform, you can deploy your app, you can preview, different ways you can interact with it. Okay. So this is a single shot prompting. Give me 1 second. I am having a little bit problem sharing my screen. Give me 1 second. Let me fix it. Please give me 1 more minute. I have to restart something. All right, I'm back. I hope everyone can hear me and see my screen. I was having a little bit problem, had to restart something. Okay, so so we talked about the zero-shot prompting. We described the whole app in plain language with no examples, nothing, and it just builds an app for us. And it built a really good app, but we can actually do better. So this is called a few shot prompt. In here, let's say we are um, building that application, and then we can actually say, well, add some features, like add a task button that will open a small window with a title field and the due date, right? So we can ask that, and we can see if it can create. The result is going to be a new task appears at the top of the list, and we are giving it an example. And then we're giving it a second example of a delete icon that will remove a task with a quick fade out, right? It will delete and it will fade out. And then now add mark a complete feature in the same style, and it will actually give us the same thing. So we can give some behavior, and then we can say, well, now mimic this behavior. So that is called few shot prompt, because we are giving it 1, 2 prompt shots before we are asking our prompt. We gave 2 examples. This is called another one. This is called the chain of thought prompting. Chain of thought prompting is a type of prompting where we guide the model to think step by step. Like, if you think you are a application builder or a product manager, how you think this application will be used by human. So you start giving it more context and then ask it to build. And you explicitly ask it to break down the task. Here is an example. Here is a bug in the app I built with Lovable, right? So feature is new users sign up with an email and a password. Let's say in that in the tracking app, we want to give the users username and password and to give the sign up steps. Open the sign up page, enter a valid email and a password, confirm the password, and click on create account button. The result is, a new account will be created. But we are finding that the page is not responding, it reloads, and no user is saved in the database. So we try to create a sign in, and the sign in is not working. Now we are asking Lovable, or we are asking Replit to think about it step by step and see what things went wrong, and then fix it. So if we just, rather than walking through this step, if we just say the login is not working, fix it, it might not know what do you mean by the login is not working. All right, so this is the chain of thought prompting, where you basically walk it through what happened and then ask it to fix it. And then there is something called tree of thought prompting. Tree of thought is, think about like a tree branch. You have one thought, and then you are asking it to branch it out. For example, design 3 different landing page for this habit tracking app for my, applications homepage. It's not, it says software as a service, but we'll say from my habit tracking apps homepage. And then, we might do some, A/B testing. We might dynamically show one, page to a group of users, or based on the time of the day, and then another page to different group of users, and see which one has more engagement, right? So this is the tree of thought, where you give it a prompt to create multiple branches and multiple alternative. And we say for each one, use a different visual style and section structure, right? And we can be more elaborate what we really want. We might say one will use light theme, one will use dark theme, one will use, different colors and see how it behaves. We can explore multiple valid approaches to the same problem in parallel using the tree of thought prompting. Then there is another type of prompt called generative knowledge prompting. This is where we ask the model to first explain or recall what it knows and then apply it to a task. For example, we can say first, explain the best practices for handling user authentication and keeping user data secure in a web app. It might say, well, the best approach is to use a multi-factor authentication, like sending you a text message, or sending you a message in your email, or a one-time password in your email, or some type of device authentication integration, like Microsoft Authenticator or some other type of application. After that, so your application will, or your platform will think about that and find the best possible approach, and then build a secure email and password login and sign up flow for your users to sign up, right? This is how, based on the ability of your platform and the knowledge that it has, you can utilize that, rather than asking it to do something that it will glitch out later on or it will not be able to do. So you're asking it basically that based of your ability, what can you build? So this is called the generative knowledge prompting. Then take a deep breath prompting. So let's say, you are trying to implement some type of logic into your application, and you see that your logic is not being implemented properly, right? You are asking it to add something or do some calculation, and you see that it is not doing it properly. What do? Then you say, well, you can sense that your platform or your large language model is trying to hallucinate. Means it's going into the wrong direction over and over. So that's when you say take a deep breath type of prompt. This is where we use some type of pacing language and encourage the large language model to provide more thoughtful responses. Basically, we ask it to reset rather than starting a whole new chat. We say, well, like take a deep breath. Take a deep breath is actually a keyword that if you tell it to the large language model, it will actually start to reset some of the information that it gave you. Not its knowledge, but the session knowledge, that chat session that it's interacting with you. And you say, think through this carefully. Given the following discount rules for my shopping cart app, a 10% loyalty discount unlocks once a member has three or more qualifying orders. Any past order below $20 does not count as a qualifying order. So now you're giving it, different numbers and say, question, on their next order, should the 10% loyalty discount be active or not, right? So now you are giving it a chain of thought, deep breath prompting using some, chain of thought, and say, to test out that whether the information is giving you is right or wrong. So we know that it has to give you 3 orders over $20. So let's say it has one order over $20, 2 order over $20, 3 order over $20, right? And then it has 4 order over $20. Okay, so it should give you. And then you can say, well, explain your reasoning. So it will explain why it's doing, and then you can test. The take a deep breath instruction improves accuracy for condition-based logic like this. Okay. So you can do that if you are utilizing some type of rule or calculation. Then we have something called directed stimulus prompting. This is where we set a role, a tone, or perspective. Like we can say, I am a travel enthusiast. Build an app for me. I am a chef, right? That I want to build an app for my followers. I am a scholar that I want to build an app for my followers, and my followers have this kind of profile. Their age range is in this. Their, you know, uh, geographical location in this area. So, based on those roles, tones, and perspectives, your app will start building things around that parameters. All right, so this is an example. Get a brand new user from the landing page to their first created project in under a minute, right? And then you are actually giving it some instructions to follow, some steps, and then how the user will go into that landing page. There is another one, chain of density prompting. This is where we ask for increasingly dense or detailed content. Like the zero shot prompting, that some of these are composite, like you start with a zero shot prompt, you ask it to build something. Then you say, well, now I want you to actually take this module and start modifying it this way. Like you say, first, build a basic weather app that shows the current temperature for the city. Then you say, now add a 5-day forecast and let users search for any city. Then you can say, let users save their favorite cities and toggle between Celsius and Fahrenheit. Then you might add another one, let the users maybe add a driving route and give them the weather around the driving route. Then you can say a very specific start time that they want to start, and then trail their driving route with the weather and see how it gets. So you can actually add these more complex, more dense and detailed prompt as it builds an app. So you are not asking it to change anything. You are asking it to build a more richer app every single time with every single prompt. All right. So when we use this prompting technique, we ask the platform to add detail layer by layer, starting from a simple app, evolving into a more full-featured application that users can use when we finish building it. All right. So these are the different types of prompts that we talked about in this session today, that you can think about them as building blocks, right? You can apply them as you are stuck somewhere, right? This is my goal. When you are building something, as you're stuck somewhere or you see something is not working, think that there is ways that you can tweak, right? You can use these prompting techniques and then you can apply them and you can build them. Some key takeaways. When you are working with these platforms, try to describe the app, not the code. Don't think about whether you are writing in Python, whether you are writing in some other code. Obviously, if you are using it to generate just the raw code, you will ask it to generate the code, but don't think about what the code can do. Think about what features you are trying to implement. The coding part, the large language model will generate. If you see that the coding actually is wrong, then you can go into the code later on. But first think about your application design, from a higher level. Think more like an architect rather than a developer when you are interacting with these applications. Start broad, then define. Start with a zero-shot prompt and then start refining and refining. Don't start with a few shot or chain of thought prompt at once. Try to build it more, layer by layer. That way, you can roll back a layer if you need to. Show examples when format matters, right? If you want some specific data to ingest, if you want some specific data to be output, give it some example that it can tell you, right? Maybe say units. If you want to, let's say, I say, I'm going to work for 30, and then you can say, well, it might need a unit. But don't ask it with a zero-shot prompt. Maybe once you see that now you can get your activity recorded, now you say, well, can you separate the unit and say, how many total, because my goal at the end is to see how many total hours of, good habit activities I'm doing every day. So I need to add up those units. And you can say, well, after when you see the app is working, now you can separate and say add the unit parameter. Debug by thinking step by step. That's why it is very important. We don't want to build the whole app, all the details at once. We want to build it step by step so we can also debug step by step. The bug, before fixing it. Set a role and be specific. You can, in your first or second prompt, you can say, I'm an undergraduate student or I'm a high schooler. I'm trying to build this app. These are the possible audience that I'm trying to make my app for. And the platform will have a very good context, and it will try to, when it's building the application, it will actually try to keep that in mind. All right. So these were the information I wanted to give you today, and we will share these slides with you. So please feel free to take them, use them, so you can be successful, not just for this hackathon building your application. You can also build more meaningful applications and do much better for everyone. Thank you. Assalamu alaikum. Back to you, Dr. Mustafiz.
Walaikum salam. Jazakallah khaira. Inshallah. I'll see you inshallah. I sent. Okay, let me stop it. Hold on.